Hello everyone, this is the user interface of my double calculator. These are my three text fields. The first two text fields denote the inputs which are given by the user. This is the first operand which denotes the first double input given by the user, and this is the second operand which is denotes the second double input given by the user, and this is the result text field. This the arithmetic operation result of these two operands is stored in a result text field, and these are my five buttons. This is the plus button is for addition, this minus button is for subtraction, this cross button is for multiplication, this divide button is for division, and this square root button is for square root. So this button performs the square plus button performs the addition operation between this two input operands. This minus button performs the subtraction between the two input operands. This into button performs the multiplication between the two input operands. This division performs the division between the two input operands. And this is the square root button. The square root button displays the square root of only the first operand, not the second operand. Suppose if there are two input operands given by the user and we perform the square root button, only the square root of the first operand is printed. Let me give you a small example. As we can see here, only the square root of the first operand is displayed in this resultant text field. Also, the name of the text field is changed to sqrt, which denotes the square root. One thing is to note that this double calculator always displays the output in the double format. Suppose if you give the two inputs in integer format, it displays the output in double format. And as you can see, the name of this text field is changed to subtract, and this performs the subtraction of the two input operands, and this performs the multiplication of the two input operands, and this performs the sum addition of the two operands, and this is changed to sum. And if you press this, only the square root of the first operand is displayed. And another thing is note that there can be a case when only one input is given by the user and the other input is left blank. So in that case, addition, multiplication, division, and subtraction is impossible. So let me just so to handle that case, we have printed the error message when only one input is given by the user. I have given the message of no value found. Let me give you a small example. So if only one input is given by the user, there is a no value found. And similarly for subtraction and multiplication and division. And as you have just observed, if you remove this input given by the user, all the resultant messages and outputs are clear. Let me give you another example. If you just remove one of the operands, the result text field is cleared over here, as you have just observed. And the square, as I previously mentioned, the square root performs the square root operation of only one operand. And there is also a case in the division when the second operand is 0, means we are dividing the first operand with 0, which is mathematically not possible. If we divide a number with 0, it tends to infinity. So to handle that case, I have printed the message of division by 0 is not impossible or impossible. Sorry, I printed the error message cannot divide by 0. It indicates to the user that division operation is basically not possible if we enter the second operand as 0, as it can tend to infinity. And here have handled that exception case in the division logic. And similarly, there are also error messages which are implemented over here with the help of a finite state machine. Let me give you a small example. Here, if I type E over here, it displays a message saying that this character, which is the next character, may only be a digit, a plus or a minus character. Suppose if I type a plus, it indicates that the next character, this pointer should be a digit. So if I press a digit, it's okay. It does not display any error message. But if I press a K, it displays a message that this character may only be a digit. And here E indicates the exponent term. That is after the number it is divided by 10, and this plus is the superscript of this 10 power 10. Uh, Suppose if it's 1.2 E plus 1, it is 1.2 into 10 power 1. And similarly, if it is minus 1, sorry, if it's minus 1, it is 1.2 into 10 power minus 1. We can also represent this as a capital E, and we can also perform the addition operation of these two numbers. Here the sum is displayed, the subtraction, the multiplication of these two numbers of exponential terms, and is a division, and this is the square root operation. So what you have just observed is that there is a finite state machine which calculates the flow of the inputs that you enter in the text field. That is the flow of characters that you enter in that text field. Suppose it indicates you the what the next character that you enter should be. So it basically gives you a hint of what to type. So it is very helpful for you. Tree. And suppose if you type anything beside first character beside a digit, which is not correct, it gives you a message that the first character must be a digit or a decimal point. So this finite state machine which is implemented in the character basically makes sure that every character which you enter in the text field is correct and is logically correct to perform the arithmetic operations between the two inputs. See over here, it displays the error message that this character may be only a E, capital E, or a small e, or a dot, or it must be the end of the input. So these are all the various possible cases of wrong inputs that are given by the user. And see over here, after one point, this pointer points to this character, saying that this character may only be an capital E or a small e, or it must be the end of the input. See, for every character which you enter, it logically checks whether the character is correct or not, whether the character is logically a number or not. And here it is not a number. It is just because it is O, which is not does not make any sense. Suppose 11.8 W. This is not a number. This 11.8 W does not make any sense because it is not a double number. But if you type E, there's a possibility that the next character may convert this into a number. It's a point. Basically, now it shows the message that this character may only be a digit, a plus or a minus character. If you type any number next to it, it converts this to a number. 11.8 into 10 power 1, which is 118, which is correct. So this finite state machine which is implemented in the double calculator makes sure that you input which you enter is correct and corresponds to a double number by checking each and every character that you enter into the double calculator in a text field. either in first operand or in the second operand. So, and if you clear any of the operands, the result text field is cleared. So this is just a brief overview of my user interface in the double calculator. Thanks for watching.